power's the same, but we shoot it twice.
Yes, cut it, cut it, cut it. Karen, I told you we're going to the hot topic.
Let's get down to it. I'm kind of excited. What's up, people? Welcome back to Casey's 80s Garage. It is the 1980s and I am in a mall. Half of that is true. I am in a mall, but instead of it being a place for a bunch of girls to go, Karen, I told you we're going to the hot topic. Something so much better than that is here. So come on, you guys. We are about to jump on to like a 1940s Bridgeport mill. Yes, like we're trying to build parts for a P-51 Mustang and get back in the air. Yes. But we're not. We're going to make an adapter plate to stick the BMW V12 M70 engine into the Boxster Porsche transaxle in the King Zero build, which is super cool. So in the future, instead of us just being a boring consumer culture that nobody cares about, let's build something together now. The trouble with doing that is, who can afford tools and mills and laser cutters and all that jazz? And even if you could, would you have a place to put it? No. So the best thing you can do is find a cool place. We've got one in Bowling Green, Ohio. It's called the Big Fab Lab. And this is a place where you can go and get trained, learn to use the equipment, and have a membership where you can actually have 24/7 access and build whatever you can come up with. And since even me, with crazy cars and builds and YouTube, hooray, I don't have space and time and money to have all these machines and stuff. So it's really an awesome just asset that this exists here. Ryan, who's actually holding the camera right now and about to trip over this doorstop, was using this place and utilizing the laser cutter and the 3D printer and all to build the taillights for the Lykan Hypersport build. There's the laser cutter. We're coming right back to it. But I am totally more into old school machine tools today. Yes. It is 8 o'clock in the morning. I have had one coffee and no breakfast. And no, for you trolls, nothing else. But I am looking forward. What can I do with my safety glasses?
They're on your head.
Oh, ha, here they are. Yes, I'm smart. Let's do this. Okay, so we got it energized. So here's the adapter plate for the King Zero build. And this bolts directly to the bell housing, shall we say, flange of the BMW engine. If you want to come in and close, I can show it to you. So this plane here that we're looking at was already cut out and made to adapt to go to the BMW motor. The original starter would be in about this position to the motor, and then here in this recess is approximately where the ring gear would be for starting the motor. And then on the back side, this bottom plane, if you can see here, with these is where the transaxle bolts. Naturally, a Porsche Boxster transaxle, regardless of whether it's the base 5-speed or the S6 speed, is a little bit smaller. Wasn't expecting a big, nasty V12, so hence you need an adapter. Yeah, it's a pretty thick piece of aluminum, but hey, we're not going to space. We're just making a supercar here, so it's gonna be pretty fun. Anyway, I just wanted to show you guys, obviously there's gonna be some old millwrights and guys out there that have done this forever and ever and ever. I did not do this forever and ever and ever, but I know at least enough information to be dangerous. Dangerous in the point of building something really cool, but not to myself. Obviously safety glasses and stuff like that. So I wanted to show you guys this, and I think it's really important for young people to have the opportunity to work on an old school mill or even an old school lathe, because it's mechanical, it's direct, it's analog. You gotta feel it. If you screw something up, you might hurt yourself or break it. And that's how you learn, old school, right? And that is the best way if you want to get smart enough to use something like a CNC machine. Because if you're just going to be a computer jockey at a desk all day in a theoretical place and never actually build anything with your own two hands, do you really think you're going to be that good at that either? No, but I digress. Let's get down to it. I'm kind of excited. I feel like we're building old, World War II airplane parts. So guys, basic things here. You've got control on all your axes here. Look at this. Right? You got to turn cranks and be all cool. All right, now beyond that, I'm not going to go into super detail on how to do this. Obviously, I know what I'm going to do. I'm going to bring back my casiness right now so I can actually do this safe, but I am having fun, and I just want you guys to see how fun this can be. So what I'm going to do here today, and come on in and look, this adapter plate, when it was done, had an issue. This relief area here was not relieved enough. It was simply wasn't big enough. And these holes Peyton actually hogged out real quick on the drill press because we thought it was just in the way of some bolts and need to clearance it. And we could do a quick dirty job to make it clearance because you'll never see it and it'll work just fine. It's not a strength issue, even though there's going to be people going, you're not doing it right. Which we are, because it'll be just fine. But instead of hogging this out by hand and making it look like crap and I just couldn't bring myself to it, it's nice to have a Bridgeport mill. So got everything set up with the bit, got it all set up to where it's ready to go. Okay, so I want to show you how I'm going to do this. I want to knock off a little bit more than this area here. I want to relief a little over 1/4 inch. Okay, so my first thing is you gotta bolt it down. You know, you got to use the proper clamps and all, and get it a nice working surface. I don't have to freak out about zeroing things or doing anything else other than just getting the surface plane on plane here and a good working space that's clamped down that I can control by hand. So the first thing I'm going to do is I'm going to bring this thing over, and I want to bring it up and, in a manner of speaking, zero it. Okay? So I'm going to get it close, and just for this technique, I'm going to turn it on, and I'm going to bring up this axis until it just touches. I know this is very quick and dirty. I'm literally just trying to knock this down. You're going to just touch? Come on. Today or tomorrow. Here we go. It's just touching, and you can see that illustrated by I can start surfacing that a little bit if I wanted to, okay? Now the reason I did that, I'm going to take the piece away so it's clear out of the way. If you come over here and look, this is the lock or the brake for this right here, but if I unlock this, make sure it's screwed in place. If I unlock that, I have the ability to move this. Now, if this is all the way up where it was, where I effectively zeroed this with my axes here, and I'm going to get this out of the way so I don't bump it, I can adjust this stopper. Okay, so if I want to just come down 1/4 inch, here's my stopper. Right there, and I'm doing this kind of quick and dirty. And you can see this only comes down 1/4 inch. And if you look at that, you know that in the sweep of this, I'll be able to take off 1/4 inch of material, which should be plenty. I'm probably going to go just a little bit more because I don't want to have to chuck up the bit and do everything else. And then here, this is my lock nut. If you look right here, this is the lock nut. No different than you'd see on like the suspension of a race car. You got to lock it in. And so I've got my adjustment here, and that's going to be what I need. So this is quick and dirty. I literally can just do this by eye, and what I'm going to do is I'm going to listen and I'm going to feel that based upon my speed and my cutting bit, I'm not overpowering it. Take a little more time than I need to, not get all impatient, and should be kind of fun. So what I'm going to do is, just to test this, I'm going to start over on one side. We're going to come over here. We're going to make sure that's up. And I'm also going to be changing this and doing 2 at once here. Here we go. This is kind of fun. All right. Now will it just touch? It just touches. So I'm going to bring it down. I'm going to go just a little. I'm going to go 1/16 of an inch to start with. Just see how it cuts with this speed at a 1/16 of an inch. So I'm going to bring it all the way over to that vertical wall. Okay, here we go. Now I'm going to go over here so I can see it. You can see well if you come over here. And I'm keeping a good eye on this. And I'm feeling this out by hand, you guys. I'm listening. It sounds a little dull. And truthfully, these bits are old, a lot of them. And frankly, I was being nice. I didn't want to go use a brand new bit of theirs. Rather save it for somebody else if they're doing something super precise. Because what I'm doing right now is pretty easy. All right, I'm gonna come over, do this sweep. Yeah, that goes through it no problem. Now, I probably could have chucked this up a little bit differently and made my life easier, but I didn't. Yeah, this is working just fine. You know, and we live in the era where schools all destroyed shop class because everything became college prep from the 80s afterward and theoretically, and just kind of ruining that. It's so important to have a place like the Big Fab Lab so young people can actually get hands-on and do things. Because the fact that you can graduate a 4-year degree in engineering and never even turn a screwdriver is basically criminal. It's completely insane. Okay guys, I've knocked out the area I need from here, right about a 1/4 inch. You can see my stopper, I went a skosh past. Yes, I know that's a technical term and people are gonna get on me a case, but hey, it's got enough. And if I get rid of more material that's not there for the sake of strength, it'll just make the car lighter and faster. Yes! I'll clean up the rest later. Actually, I wanna get back to the shop. The guys are all getting there and then Ryan's gonna do some laser cutting, which is really cool. But I do see where the guys did their relief for where the bolt heads are, and my carbide cutting bit here is a little bit bigger in diameter. So I think what I'm gonna do is I'm gonna go back over this real quick and I'm just gonna knock off a little bit of room, a little bit more relief for where those bolt heads were with the guys. So, okay, there's about that. How far do I want to go down? Oh, you know, something reasonable. We'll take that another 3/16 of an inch. Okay, so what I'm gonna do, get that off of there, go up a touch. You're gonna fire it up, and I'm gonna do this, just do it by hand real quick, and I'll relief it a little bit more. I think I removed plenty of material for where some of the casting of the motor will get in the way, but I wanna make sure that where those bolts are, it's not gonna hit at all. And this bit's a little bit bigger than what I got here, so it should be no problem at all. Checking my speed. Well, helps if I unlock it. And we're just gonna release this, go down, and the stopper's gonna tell me when. Looks like it's cutting nicely. And as a note, I slowed down the speed of the mill here. Frankly, it was going too fast, and my bit's a little dull, and it was going fast enough, it wasn't able, and during each swipe, when it's spinning, wasn't able to, I'm gonna get rid of that flashing stuff there. It wasn't able to cut enough. So I slowed it down, I just relaxed a little. Obviously, you know, I'm making a video for you guys, but it's still important for me to do a good job with my machining. Fortunately, this piece, the tolerances are very low. I can kind of just get in here willy-nilly. If I was doing something super precise, and I was gonna do a video of it, the production would take a long time, just because I couldn't, in that circumstance, I wouldn't be able to concentrate as well. But here, we're just doing something quick and dirty, and I hope it inspires you guys. It sure is empowering to get to do machining like this. You know, I find anytime you get a new tool, whether it's a welder or a machine tool, you don't wanna just do everything with it. You know what I'm talking about, the type, there's engineers and stuff out there that like they learn how to do carbon fiber, so now they have to do everything in carbon fiber. Or they like get a new machining tool and then the only thing they know how to do is machine. That's kind of annoying because I think it's important to use the right tools for it, and just because you have something really fancy or computerized doesn't mean you should use that for everything. Oftentimes things that are computerized just end up taking a heck of a lot more time than if you just did it yourself quick. And there's also a lesson in terms of being perfect enough, okay? And that's what we're doing today, we're being perfect enough. So, you know, I think this is really neat. And in terms of just kind of like a little philosophical moment looking at history, you know, this machine has got some years on it. I'm not sure when it was built because quite frankly, machine tools are just as viable from the 30s and 40s as they are now. But, you know, if you think about it, I made that comparison, or I mentioned about putting a P-51 Mustang back up in the air, and old school machining. And you know, if you looked at back in World War II, American manufacturing was all about do something well, get it done right now, make it work, and make it something that's gonna be functional and fixable. And that's what you need to win a war like that in that time in history. And it's kind of neat because something that if we talk about in the scope of wartime, of doing something that's quote unquote great, but you know, a great feat, shall we say, of ingenuity, engineering, daring building, and just all those good things to do something that's inherently bad or difficult. Now, that same ingenuity and know-how and machine tools, instead of making war machines, gets to make a super cool, avant-garde, arty supercar. Which, you know, maybe isn't as cool as a P51 Mustang in a lot of ways because it's not going to use up a whole 9 yards. But it's pretty nice that we live in a country where you can go out and build your own supercar. So I'd hope that inspires you guys to join a place like the Big Fab Lab in Bowling Green, Ohio. Go to a trade school. Don't stick your nose up to things like that just because stupid college prep has been doing that for the last 30 years. Because you can build amazing things and make your dreams come true and do things that are, have a lot of ingenuity for the future. So I tell you what, I'm gonna clean this up, but let's go see Ryan with the laser cutter. Okay, so here is what Ryan's been building here for the Lykan Hypersport before I actually came in and did it. You guys are gonna remember this from the Lykan build. Here's a prototype PLA part for the taillights, and here's one of the functioning taillights off of his Lykan.
Yep. Okay, here's the final piece here. This one's a little dirty from our trip to Road America, but yeah, this is the final piece. There's still a little bit more I need to do to it, but
go ahead and flip it over.
Other than that, yeah, here's the
nice
bolts that I bonded in for mounting, and yeah, we actually are using the stock connector from the Boxster. I was able to get it out of the previous tail light and was able to wire this all up to it.
For sure, it looks awesome, man. And you guys can probably tell that's not finished. We got to finish off the sides, make them look pretty. The wiring's going to change and whatnot, but they are working good. And for anybody that was at Road America or saw it there, obviously the car's not done, and the body got shot out of a second-story window a couple of times, basically in stunt. So it's not that pretty, but we wanted to show you guys a work in progress and inspire. But we're going to do some laser cutting and show you that machine.
Yep.
And the laser cutting is exactly how Ryan was able to knock out these lenses perfectly and have a beautiful beveled edge. So we don't have, let's go check it out, but we don't have any lights to cut out right now. So what we're gonna do is just kind of a test piece on some scrap of something cool with the King Zero. But we are gonna come back to laser cutter for the Lykan headlights. And the big question is, how many carats of diamonds are we gonna put in this thing?
I don't know, enough.
Yeah, W Motors did 15.
That means we need to do 16.
Yeah, except I don't know. We're not as oil rich here.
That is very true.
We'll see how it goes. Anyway, here is the laser cutter. Ryan, what have you done?
Okay, so with this design here, I was able to take a picture of the
Nice.
image you drew, and
Yeah.
I was able to.
This is hilarious. So you guys remember I did the picture I just drew real quick in time lapse of like, sorry Avalon King, I'm not doing a commercial, building a supercar, way cooler. So he just took that picture, put a circle around it. This looks pretty easy, man. Like, is it really that easy?
Yeah, the hardest part was turning this into a vector image, but with the software they have here at the Big Fab Lab, it was really easy to get it done, and it's all connected to the printer, or not the printer. So it's the 3D printing stuff, the laser, and I sent the job over, and it's ready to start cutting.
That's super cool, like literally right now.
Yeah, literally right now. I could close the hood and press go. And
That's awesome. So you guys get that, right? Like literally a high contrast drawing. We took a picture of, stuck it in here, and it was able to create the vector image for scaling and all. Let's do it, man. I want to see this.
Yeah, laser cutter is very entertaining to watch. Okay, close the hood here.
Okay, he's got it figured out.
Good job.
Mm-hmm. Yeah.
Let's try this again.
This is the Kobayashi Maru.
There we go.
Oh, it's doing stuff. Look at that. Yes. We're back with Ensign Ryan. He is a total red shirt, and he's cutting again with more power.
Yes.
More power. Yes. Ooh, that is more power. I like that.
Yeah.
I want to get in on that action. Man, it's having a hard time focusing. Focus, focus. Yes. Cut it, cut it, cut it. Ooh. It is etching much better without that protective covering. Mm-hmm. You see that? It's getting into the surface.
Yep, just a little bit of the, I can't remember what the technical term is, but I feel like the frosting from the actual material being removed from the surface, but we can clean that up.
Yeah, this is nice. This is really nice. All right, it's gonna cut. Cut it, cut it. Yes, cut, cut, cut. Because there's one cut. Oh, here comes the second. Oh, burning through.
Oh,
yeah, that's awesome.
Through.
It's all the way through. That little flash is from the supporting area underneath there, right? Where it just touches it?
That or the a slight flare up when it's touching the backing of this. It tends to burn it a little bit.
Okay.
You can tell from when we were cutting off the headlight up here.
We'll yank it out.
Yep, that definitely went through.
Yes. So we'll come back with this, you guys, on the Lykan Hypersport build. And Ryan, he's doing the headlights. Currently, he's making the buckets and doing some things out of actual sheet metal fabrication and readying the high-intensity discharge headlights. but there's going to be some beautiful acrylic in there and facets that he'll be cutting with a laser. And that's especially nice for the Lykan Hypersport, because if you guys can see right here, that is very pretty. That is a very beautiful cut. And that's exactly what he's going to be doing for the headlights on the Hypersport. So it's going to be really pretty. But today we made a fun little keychain kind of thing of the King Zero. Hey, that's cool. But anyway, I hope you guys enjoyed this. Ryan, thanks for helping me out on this. We'll come back, actually. And more than important than that, thanks for getting up so early in the morning on Monday.
Yeah, it was fun.
Okay, I hope you enjoyed showing this. We're going to interview Ryan here soon. He's going to stick around another couple of months and maybe get in on an IndyCar project.
I would love to. That'd be awesome.
I think it'll be cool to take Ryan's talent from doing 3D printing in your computer software, but now applying that to machining and engineering on an actual car chassis. So it's gonna be fun. Anyway, guys, hope you guys enjoyed this here at the the Big Fab Lab in Bowling Green, Ohio, or BG. This has been a fantastic place that has allowed us to help create those specialty items for the Lykan Hypersport, as well as my King Zero build with the engine mount plate. Yes! So, hope you guys check them out and put a link in the description below. I'll see you guys next time.